Hi there, welcome to part 2 for your lesson on limits, where we're going to continue what we started in our last lesson. Make sure you watch that video first. Alright, so this is where we ended off in the last video. We had this function, we graphed it, it looked like a line, which was strange, but we also noticed that it had a hole at x equals 1. And we know there's a hole because if you substitute an x value of 1 here, we'll get 0 in the denominator, and that's undefined. Therefore there's a hole there, or a discontinuity. But just because a graph has a hole in it doesn't mean it cannot have a limit at that value. So the limit as x approaches 1, so as we come to x equals 1 from the left and also from the right, we get to the same value because as we're approaching 1 from the left and from the right, we see y values converging on the same value, which is 2. Even though it doesn't exist at that point, just the fact that the two sides lead us or are showing us going towards the same number, we can still say the function has a limit at x equals 1, and that limit is 2. Alright, let's take a look at what happens with that one. So there's that same function. Let's solve the limit algebraically. So we have this function. As you know, if we plug in a value of 1 in there, right, we're approaching 1, but if you put 1 in there, you end up putting, so 1 in here, 1 in here, you end up with 0 over 0. Undefined, that doesn't work. So we already know there's a hole at x equals 1. But what can we do with this function? We know we can factor that. The top is a difference of squares. It factors like this. And now we have x minus 1, x minus 1. We can cancel both those away. And we're left with just x plus 1 here. So now we can say limit of x approaching 1 of x plus 1. And if you put a 1 in there, 1 plus 1 equals 2. So we found out what value it approaches. Basically, we canceled away the discontinuity here, and we found out it approaches 2. Alright, there are more complicated functions than this one, but that's as complicated as we're going to look at in this course. These ones where it can factor. Otherwise, you just use the graph to figure out the limit. So let's look at this one. This is a little bit different. This has what is called a piecewise function. That means the function takes on one equation for a certain domain and another equation for another domain. In this case, we're looking for the limit as x approaches 0 of this function. So first of all, how do we graph a piecewise function? Let's remind ourselves. So what this means here basically is when x values are greater than or equals 0, then the function is f of x equals 1, or y equals 1, right? F of x is just like y. And we know y equals 1 is just a horizontal line. And also now for when values of x are below 0, because this is when x is greater than or equal to 0, when x values are less than 0, the function equals negative 1. So basically we have two possibilities for this function depending on what x values we're talking about. Now how do you graph y equals 1? Well, that's just a horizontal line at y equals 1. And we know that that line exists for x values greater than or equal to 0. So notice how I started at 0 and I went in this direction. And I did a solid circle here to show including that value because we include 0 here. And then we graphed the line y equals negative 1, which is down here, when x is less than 0. And notice here, in this case, I had that open circle appearing. So there's the line y equals negative 1, and there's an open circle because it does not equal 0, so that line exists only for values less than 0. So there's our piecewise function graphed. Now remember, when we do limits, we come from the left and from the right. So what happens when you approach x0 from this side and x equals 0 from this side? There's a table to help us with limits sometimes. In this case, we can't enter this kind of piecewise function in our calculator, so we're just going to write the values in this table by looking at the graph, because in this case it's very doable. So we're saying we're approaching x equals 0 from this side. Okay, so we begin at x equals negative 1. What's our y value? Okay, it's negative 1, right? Because over here the y value is negative 1. Okay, let's say we get closer to 0, and now we're at negative 0.1 on the x, so somewhere over here. What is the y value? Well, the y value is still negative 1, right? So as we approach 0 from this side, the y values remain steady at y equals negative 1, and we can see that here in our function. Okay, what happens when we approach from the right side? Okay, now x is 1, so we're standing over here. What is the y value right there? Well, it's 1. Okay, now we're going to go closer to 0 from this side. Now we go to 0.1 on the x-axis, so right here. What's the y value? 1 again. And then what happens when you get to 0? Well, at 0, is the y value here or is it here? Well, this is a closed circle, so that's where it exists. The function doesn't exist here. So when you get to x equals 0, the y value is 1. So what this tells us is as we're approaching 0 from the right side, the y value seems to be 1. As we're approaching 0 from the left side, the y value is -1. They are not converging on one single value. Therefore, this function does not have a limit. So we say it's divergent and the limit does not exist. All right, remember that you have to approach the same value from both sides in order for a function to have a limit. Okay, let's try this one. So do this, take this graph here, enter this function on your calculator, graph it. You should already have kind of an idea of what it looks like. You should already know maybe where the vertical asymptote is because we have this denominator here, right? So graph it and see if it matches the graph we're going to see. So we'll see that graph in just a moment, but also after graphing it, find the limit as x approaches 3 numerically. That means use that table of values. So create a table of values with values close to 3. And let me just remind you how to do that again. Okay, so we have our calculator. We're going to enter our function. To calculator, you go to y equals, you enter your function like I did there. So make sure you enter this function. Okay, next we want to see the table of values. So we're going to do second table set, and then there you have to choose your starting value and then the increments that the table is going to move by. So I'm trying to get close to x equals 3, and I'm starting on the left side, so I'm putting 2.9, that's pretty close, and I made a small increment of 0.01. So if every value in the table will jump by 0.01. And now you go second and table, and it will show you the table. Instead of the graph, it will show you the table for this function. So here's a table. So when x is 2.9, y is 5.9. When x is 2.91, y is 5.91. And look as I go down the table. As I go closer and closer to 3 on the x's, what does the y seem to approach? Look at those values. Okay, well, it definitely looks like y is approaching 6, right? So now I'm going to pass that point. Oh, look, at 3, there's an error, because we know if we put an x value of 3 in here, we'll get 0 in the denominator. That does not exist. All right, but then you're looking at approaching 3 from the other side. So I have an x value of 3.04. I have this y value. X value of 3.02, 6.02, x value of 3.01, y value of this. So as you go from both sides, and it can be clearly seen in this table, as you approach x equals 3 from both sides, the y value seems to approach 6 from both sides, even though it doesn't exist at x equals 3. So that's how you use a table feature. So now let's look at our graph. Here's a graph. This is similar to the one we looked at earlier. It looks like a line, but there's a hole at x equals 3 because x cannot be 3. And it tells us here as well, right? So there's a hole there. And then we know that the limit is 6. We just saw that from the table. That this graph approaches 6 from both sides. So when x is 3, the y values are approaching 6 even though they don't exist right there. All right, looking at it algebraically, we have our limit statement. We can factor the top, or sorry, first if you put 3 in there, if you substitute that 3 value in there, you'll get 0 over 0. Again, that's similar to what we looked at before. That doesn't work. So instead we look at it, we think about the top, it can be factored like this, cancel those two, and then we're left with this limit, which if you substitute a 3 in there, it is 6. So it confirms what we saw in the table. Okay, those are simple limits. We should feel comfortable with those. Let's look at one more. So you have this graph here, and you're going to graph it and find the limit using the table. And so see how it shows you here? Find what x values are, and what limit? Yeah, you're looking for the limit as x approaches 0 from the negative side, and as x approaches 0 from the positive side. So again, you're making 0 that thing you're checking in your table. What's happening to y values as x values are approaching 0? So graph it, check your limit, and let's see what happens here. Okay, so here's the graph. This graph again has a hole at x equals 0 because if you put 0 in here, you get a 0 denominator value. So we know there's a hole there. And then if you check the table and you come from either direction, you should notice a limit of 1.1. So I hope you're able to set the table in enough detail so that when you looked at approaching x equals 0 from both sides, you were able to get that same value. Okay, try this one here. We have a function here, sketch it, and then talk about the equations of the asymptotes. Well, I'm going to end off by showing you this one. So we know this is a rational graph. This is what our last unit was all about, rational functions. So this one here we know is going to have some asymptotes, and it's going to have this general shape. All rationals look like that. You can confirm on your calculator. We know it has a vertical asymptote, so this says x minus 1. So to find the vertical asymptote, we set the denominator equal to 0. we solve and we find out it has a vertical asymptote at x equals 1 right here. There's a hole in the graph. Now, looking at this in the language of limits, check it out. What happens when we are approaching this x value of 1 from both sides? So as we are approaching 1 from the positive side, that means over here, so x values are approaching 1, we're getting closer to 1. What's happening to y? Well, as we get closer to 1, the y values are going up, all the way to infinity. So notice, as x approaches 1 from positive side, the y values approach infinity. And now we're going to approach 1 from the negative side. So now I'm approaching x equals 1 from this side. What's happening to the y values? Well, they're approaching negative infinity. As I get closer to 1, these go down, down, down forever, so the y values approach negative infinity. So we can see that we tried finding the limit from both sides, and it's two different values. Therefore, x equals 1 is our asymptote. It's kind of telling us there's a wall there. Now to find the horizontal asymptote, remember you take the coefficients of these two numbers. So there's 2 and there's a 1 in front of that x in the denominator. So our horizontal asymptote is 2 over 1, or 2. And we can see on the graph it's right here, y equals 2. Now look at that in terms of limits as well. So we have, as x approaches infinity, so here's this, as x values approach infinity, we go all the way to infinity here, what do the y values approach? Well, they approach a value of 2. So as these x values go to infinity, this is getting closer and closer and closer to y equals 2. And then we can go, as x approaches negative infinity, so now as x values go towards negative infinity, the y values also approach 2. So that tells us there must be a horizontal asymptote at y equals 2. And the limit exists. The limit of that function exists. This limit did not exist, but this limit does exist. Yeah, we can see it's a limit of 2 from both sides. All right, we can do it. We're going to do more problems like this tomorrow. Great job. Thank you for hanging in there for 2 lessons. Limits are a key part of calculus. They are the first step. Hope you have a good understanding at this point.